Did you know that there are projected to be 60,000 satellites in orbit by 2030? And just between 2022 and 2023, there was a 35% increase in the number of satellites. And considering that the lifespan of most of these satellites can range from several years to several decades, we must design them with the utmost care, keeping in mind that failure is, well, costly to say the least. And one major design concern in all satellite applications is RF. And that's exactly what we're talking about today. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Maria Calia from Amphenol Times Microwave Systems, Daniel Hallstrom from Amphenol SV Microwave, and I explore the use of RF technologies in satellites, the biggest design concerns with connectors and cabling in satellite applications, and why RF cable failure mechanisms can be managed by a careful selection of materials and manufacturing techniques. And before we get started, don't forget to click that link. There you can find even more information about this topic. Hi, Daniel. Thank you so much for joining me.
Hey, it's good to be here.
And hi, Maria. Thank you for joining me.
It's great being here today. Glad to be here.
Excellent. Okay, so I'm excited to talk about RF applications in satellites today. But before we dig into the details, talk to me a bit about your divisions at Amphenol.
Sure. So Times Microwave Systems is part of Amphenol Corporation. Amphenol today is the largest interconnect company in the world. Times itself was founded in the 1940s, so you could say that Times is one of the pioneers in the industry as far as RF interconnects go.
So SV Microwave is a bit newer. We're founded back in 1968, and we got purchased by Amphenol back in 2005. So since then, we've been running much the same. We've stayed separate from Amphenol as a whole. We've really specialized mostly in inside-the-box solutions on PCB RF connectors, and that's where our specialty lies. For most of our history, we've catered mostly to military consumers, but recently we've been expanding to more commercial markets, especially in the space and satellite industries.
We're unique in the market in the sense that although we started in the military aerospace markets, and that's been the bulk of the business that we have, with all kinds of solutions that could be mostly outside the box and some inside the box. But I would say that in the last 10, 15 years, we have expanded in commercial markets. So we are unique because we can actually play in both high reliability spaces and commercial. That's why we have a global footprint. We have factories overseas as well with China and India, but we also have factories in the US. And in the US in particular, we are partnered with SV at multiple locations, namely West Palm Beach, Florida, and Mesa, Arizona. We have neighboring factories, which allow us to cooperate more efficiently. Times started as a cable manufacturer. SV, as Daniel explained, interconnects a lot of connectors. So we can supply cable to SV and they will put their connectors on, or vice versa. We'll get connectors and put them on our cable. And we work together efficiently. So we let the customer drive. So it's based on applications. And because of the breadth of products that we can offer into the market, we can pretty much cover every application. We don't have to sell a specific product. We can tailor to the customer requirements. So as you might have gathered, we do have a lot of technology, and also we have highly technical teams. We have a lot of engineers as part of our staff in manufacturing, as design, as process, a lot of different areas.
So, talk to me about where this RF content is being used.
So RF content is mostly used in the payload itself. There's just a lot of communication operations going on in space right now, especially in LEO and MEO orbits. So our payloads can be used for imaging. We can track hurricanes, weather information. We can provide surveillance or any other type of imaging or communications uplinks. More recently, I've been working with a lot of phase arrays and multi-data link applications, which have a very high density RF connections. And it's been really helpful for them to be able to use those high density applications in some of their products. So we have a wide range of applications, basically anything communication oriented on your satellite will use RF at some point.
And Times as well can also provide some inside the box. I would say for the electronics RF assemblies, we do have phase stable technologies at temperature, which are perfect for the ranges that the satellite is exposed to in LEO, like the Instaband, for example, the Instaband product line. And we'll dive more into the details here in a minute. But we also can provide the longer runs, which will be the ones that go from outside the box or where the boards or the processing units are to the antenna, for example. So those would be typically larger diameter RF assemblies, which would fall into our max gain space product line.
So between the two of us, we can cover you on most space-based applications, running all the way from the antennas to anywhere else you need on your frames.
So let's talk about the signal path in these applications and the challenges inherent in these designs.
Yeah, sure. So anyone who thinks about a cable at first will say, wow, what can be so hard about a cable? It's really just some length with two connectors, one on each end. The reality is that even though the cable is carrying a signal that's been already well characterized in many textbooks, the reality is that this cable will go from a location to potentially somewhere remote. And even if it's not going through a location, it may be a short run, it may be in a tight spot where it has to be flexed and routed, which, all these things can affect the performance of the cable. But it could be going to isolated boxes. It could be crossing from a much more controlled environment, if you will, within the spacecraft into a much more exposed environment where you now have to withstand temperature and more radiation. So because failure is costly, you want to make sure that you're selecting the right cable for the application. So how do you go about doing that? It's really not that easy for a couple of reasons, because first, the reality is that most designers, they worry about the RF cable only at the very end. So that's basically when most of the equipments have been designed already, their spacing is pretty much defined. So now, because the cable wasn't specified, now they have to think about routing it. And typically something has to give, meaning that there's going to need to be a compromise of some sort. So it may be performance versus mechanical fit, because there are trade-offs. The larger the size, the more difficult it's going to be to route. To give you an example. So at the end of the day, I would say it's important to actually engage the right suppliers early and have that flexibility to really get the best RF coaxial technology for that application.
So, what are the biggest design challenges we need to keep in mind here? And it's vital to have access to a wide selection of different designs, constructions, and materials, right?
Absolutely. It's important not to compromise. That's what I would say, because there are many suppliers out there, there are choices. However, what I would say is it's important to work with a supplier that has access to a lot of different constructions and materials, because it's going to give more flexibility. Space is the harshest possible environment. There is no atmosphere in space. So that means that the RF cables, regardless of where they are, they could be more embedded in the spacecraft, they could be maybe more external, but they're all going to be exposed to radiation and to temperature. And before even that's the case, they have to actually withstand launch first and survive that. And by the way, once they get there, they're expected to survive or live and operate for 1 year to maybe 5 or even 7 years. So it's important to work with someone that not only has access to materials, but understand how those fit together. Because there are standards out there that tell you how to, for example, design a coaxial cable. And there is standards out there that tell you how to design an RF connector. However, there is no standard that tells you how to put those two components together to get an RF coaxial cable that will last over time.
So, keeping payloads in mind from what you mentioned earlier, what kind of solutions does SV Microwave and Times Microwave Systems offer here?
So I think this ties back to what we were talking about earlier. So as far as actual individual solutions go, that's where SV comes in with our high density interconnects and our multi-port solutions. Those have been extensively used in space and are able to withstand the shock and vibe in other environments that you guys are going to be dealing with, just like Maria was talking about. We also have a line of ultralight RF connectors, so we know that every gram counts when you're launching in space, especially when you have highly connectorized assemblies where you have very high density. You want to make sure that every single ounce that you have counts. And again, this comes in with Times' products like the InstaBend, the MaxGain. All of these products are highly specialized to deal with all the environments found in space. I mean, they're rated for outgassing. They're designed to deal with multi-paction. We use the correct types of solder for whiskering, and we have vibe standards for all of these things. So when you are designing an application for space, it's still important to talk to someone who can help you select the best products. But many of these products are available as standard COTS products. So you can find these and help do prototyping and other things with very quick turnaround times.
So, can we also take a closer look at the high density interconnects you spoke of earlier?
Yes, so our high density interconnects use either fixed or spring bullets or tightly packed multi-port blocks, as you see in these images here. These can be used as surface mounts or edge mount connectors. We're also developing multiple ports simultaneously next to each other on a board, so you can have 100 to 200 lines of RF going to a single board. These all use SN63 or other types of tinning to avoid gold brittlement and whiskering. They adhere to J standard 001, class 3. Our spring bullets are really useful for vibe or shock situations or when you have tolerance implications on your PCB stack-ups. Our high-density interconnect are popular in LEO applications, especially where you have really tight packages and things like that. Whenever you're dealing with CubeSats or any kind of space constraints, that's where SV can really come in with these multi-port high-density configurations.
All right. So, what about the connection of payload to data processing? Can you talk about the solutions here?
Sure. For example, the SV ultralight RF connector is 33% lighter than the stainless steel counterpart. This is for application where every gram counts. Even though in commercial space today, the cost of launching a satellite is greatly decreased to saying from 15 years ago or even 10 years ago. One thing that is worth pointing out is the fact that LEO is typically comprised of constellations that could have anywhere from one, three, or sometimes hundreds of satellites. So even though one connector may not make much difference, if you have hundreds of these or thousands of these, especially in the tight applications that Daniel was talking about, it becomes critical now to work with lightweight materials. And then from the time side, our Instaband RF cable assemblies are designed for the tightest possible space. So, where, for example, even inside a box, from a board to the box, where there is very limited space and maneuverability, you can route this cable very easily because, unlike standard technology, which is using a solder joint, which can also be considered a failure point, if you will, we now have a special clamping mechanism that allows you to bend the cable right at the end of that connector as opposed to waiting some distance to start routing the cable to protect that solder joint, which is critical to the electrical performance of the cable. And what's great is that the Instaband cable family comes in a variety of dielectric materials. So we can support applications where loss is the most important parameter, or we can support applications where phase stability is a very or critical parameter. And phase stable arrays are becoming, like Daniel was saying, more and more common, especially with applications like SAR, synthetic aperture radar, becoming more prevalent in the market and actually becoming commercially viable. So having the ability to supply COTS for this type of application is basically not only reducing the time to market, but it's enabling the space, the commercial space market, to leverage the latest technology out there. And then as far as the MaxGain space RF cable assembly, those are designs for longer runs. So whenever you now need to go a larger distance, by definition, because you have to carry the signal and you want to preserve as much of the signal as possible, you typically run with a larger diameter cable, which is going to have a lower loss overall. And if it's going from the box, say, to the antenna, now you have more room to maneuver. So the size is really not an issue anymore necessarily. Again, you have access to assemblies that can handle some power even if needed.
Okay, so what would you recommend to help find the best solution for these kinds of applications?
I would say that it's all the things we talked about today: understanding the environment, understanding the system, looking at the system and distance that needs to be covered, for example. Where is the cable going to be routed in? Is the application inside the box or outside the box? Is the cable run short or long? Is it a really tight space where now high density is going to be the only possible solution? All these are questions that the system design engineer is going to know the answer to. So, if, for example, if loss is more important, does he have space to maybe route the largest cable? If not, what's the best compromise? Compromises are typically going to be normal in LEO applications or MEO or GEO, whatever that may be, because there is no perfect solution. But there is going to be definitely a solution that covers most of the requirements better than others. We believe, as VN Times, as part of Amphenol, that we can offer these solutions to our customers.
So, what would you like my audience to take away from today's Chalk Talk?
I'd say the most important thing to realize is that with Amphenol, with all of our different divisions, the most important thing to know is that when you have RF needs, SVN Times Microwave Systems have you covered as far as space-based RF communications go. If you guys needed a subject matter expert or anyone to talk to, feel free to reach out to either one of our teams. We'd be happy to assist you. Most of our COTS products are space level, and they are reliable in many space applications. So we can help work with your team to get you prototypes as soon as we can to be able to help support you as our customers in the best way we can.
Awesome. Well, I think that's all I have time for today. Thank you so much for joining me, Maria.
Sure, it was my pleasure.
And thank you for joining me, Daniel.
Absolutely. Good to be here.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.